Hello students, welcome to the third lecture on the lecture series on work and time. So previously what we are doing was we covered all the concepts and types of problems that are usually asked in the all competitive exams, and we did some exercises on last lecture. Okay, so we will continue to do so in this lecture also. So let's go forward with this lecture and do some exercise problems. So this will be the third lecture on this lecture series on work and time, and we'll be covering exercise problems. So let's see problem number 1. So if it takes Sam 10 hours, okay, Sam takes 10 hours to complete a task. Okay, in order to complete the task, he needs 10 hours. Right, so what is his work rate in terms of tasks per hour? So work rate is equal to number of tasks, right, by time consumed or time for completion, right? So this is nothing but one task and it took him 10 hours. So this much amount of task per hour, okay, is his work rate. Okay, Sam's work rate is equal to 1 by 10 tasks per hour. So let's see the step-by-step solution. So calculate the reciprocal of the time taken, that is 1 by t, or time, that is 10 hours in this case. Okay, so reciprocal of time is equal to 1 by 10. Sam's work rate is 1 by 10 tasks per hour. Okay, so let's go forward with problem number 2. So problem number 2, it asks us that when working together, A and B can actually complete a task in 5 days. Okay, if A and B both involved, this implies T completion is equal to, that is time needed for completion is equal to 5 days. Okay, if A alone takes, so TA completion, that is the amount of time A took to complete that task, exactly that task, okay, is 10 days. Okay, so the question is how much time will B alone take to complete the task. Okay, so let's go forward. So what we do, we set up the equation based on our work rates, that is work rate of A is equal to what, 1 by 10. Okay, 1 by time, that is 10, this much task per day, right? So this is the work rate of A. And what will be the work rate of B? Okay, that is what unknown here. So work rate of B is equal to, we don't know till now, but we can evaluate. Okay, let's see how we can actually evaluate. So we know that the combined work rate is equal to 1 by how much? This is 5, right? And we know the formula for combined work rate, right? 1 by x plus 1 by y is equal to 1 by 5. So what is 1 by x here and what is 1 by y here? X is the amount of time it took for A to complete that work, and y is the amount of time that B took to complete that work. Okay, so here given that work rate of A is 1 by 10, so x is replaced by 10, so 1 by 10 plus 1 by y is actually equal to 1 by 5, because work rate of B is unknown, that is equal to y. Let, okay, so this is given, right? So 1 by y is equal to nothing but 1 by 5 minus 1 by 10, that is equal to nothing but what? It will be 10, so 2 minus 1 is equal to 1 by 10. So this implies that y will also take 10 days to complete that work. Okay, so work rate of y is equal to 1 by 10, and the time that it will take to complete exactly that work will be 10 days. Okay, so yeah, proved here y will be equal to 10, that is B alone will take how many days? 10 days. Okay, as much as A gets. So A plus B is 1 by 5, work rate working together or combined work rate. So if A is equal to 1 by 10, that is A's work rate here, so then finding B's work rate. So we use that equation and just made something around here. Okay, and we got 1 by 10 out of it. Okay, so calculating B's time for complete the task is 1 by B, so B days, okay, that is 10 days. So 10 is the correct answer here. Okay, so let's go forward to the next question. So let's see problem number 3, right? So here again similar kind of case is represented, that is A can complete a task in 12 days. Okay, A, the person, can complete the task in 12 days and B can complete the task in 15 days. Okay, so A's work rate is 12, B's work is equal to, sorry, this is 1 by 12 and this is 1 by 15, right? So how much time will they take to complete the task working together if they each reduce their work rate by 20%? Okay, so here is the culprit available. Okay, that is the working together, they reduce their work rate by 20%. Okay, so basically what happens next is, when individually working, A works at its 100% efficiency and B works at its 100% efficiency. But now what A and B does is, they work at 80% of their capacity. Okay, so basically A's work rate will be 80%. A is new, so A's new work rate is equal to 80% of 1 by 12. That is actually A's old work rate, right? So this is equal to 0.8 into 1 by 12. So this is equal to nothing but 8 by 120. So this will be what? So this will be 460 to 30, 1 by 15, right? So 1 by 15. So A's new work rate is 1 by 15. Okay. So B's new work rate. So B's new work rate is equal to 0.8 into 1 by 15, right? So this is equal to 8 by 150. Okay, so this is nothing but 4 by 75. Okay, this is equal to 4 by 75 is B's new work rate. Okay, so their combined work rate will be what? So their combined work rate will be 4 by 75 plus 1 by 50. Okay, so this will be what? 4 plus 5 by 75, that is equal to 9 by 75. Okay, so this is their combined work rate. Okay, so how many days will it take for both of them to complete the task? Okay, A reduced plus B reduced is equal to 1 by T. Okay, so their 1 by T becomes what? Their 1 by, so A reduced is equal to what? A reduced is 1 by 15 and B reduced is 4 by 75. Okay, as we have evaluated here. So 1 by 15 plus 4 by 75 becomes 1 by T. So solving for T, what we are left with is 75 by 9. Okay, because 1 by T is equal to what? 9 by 75. So it will be nothing but 8.33 days. This much amount of days will be required for A and B after their reduced capacity of working to complete that same task that they individually solved at or completed at what, 12 and 15 days respectively. Okay, so let's go forward with the next question. Okay, so let's see problem number 4. If A can complete a project in 12 days and B takes 9 days to complete the same project, they start working together. But after 4 days, what happens is A leaves and B continues to work alone. So how long will it take for B to complete the remaining work? Okay, so A and B combinedly worked for 4 days. So let's work out their what? Fractional work done. Okay, so let's first calculate their individual work rate. So individual work rate is A's work rate is equal to 1 by 12. B's work rate is equal to 1 by 9. And combined work rate, combined AB, WR work rate is equal to what? 1 by 12 plus 1 by 9. So this will be nothing but 12 here. But not, it will be 36. 36, so 3 plus 4, so 7 by 36. Okay, so let's see. So calculating the fraction of work done by A and B. So fraction of A, work done by A will be 4 by 12 and work done by B will be 4 by 9. So calculating the remaining fraction of work to be done, okay, so it will be equal to what? Because work rate of A is 1 by 12, right? And work rate of B is 1 by 9. Okay, we can also do what? We can multiply with 4. 7 by 36 into 4, because in one day they complete this much amount of tasks. So in 4 days, how much will they complete? So this will be 9. So they will complete 7 by 9 of the work. So 1 minus 7 by 9 is equal to the amount of work remaining. Okay, that B will be continue to do after A leaves. Okay, so this much amount of work is remaining. So this is nothing but 2 by 9, right? Remaining work. So if this much amount of work is actually remaining, then let's solve for how much time will be take to complete the remaining work. Okay, so this will be time is equal to work by rate. So B's rate is nothing but what? 1 by 9, right? So this will be 2 by 9 whole by 1 by 9 is equal to 2. So it will take B to work for extra 2 days, okay, to complete the whole task. So this is this. So remaining fraction of work by time taken by B, this will be nothing but approximately 2 days to complete the whole remaining work. Okay, this formula was used there. So let's see problem number 5. So A and B can complete a project in 10 days. Okay, combined workforce of A and B can complete the project in 10 days. So if A leaves after working for 4 days, how long will it take for B to complete that project? Okay, again what we'll do is we'll calculate work rate of A is equal to what? 1 by X, let, and work rate of B is equal to let. Okay, so A leaves after working for 4 days. Okay, in 4 days what A does is A leaves the work. Okay, so their combined work will be what? 1 by X plus 1 by Y. Okay, so this, and this is the combined. Okay, so if they complete it in 10 days, so in 10 days how much will they be completing? So it will be 10 by xy into y plus x, right? This much total work. Okay, so something is missing here, that is I think the amount of time it takes for A or B. Let's say for A to complete the task, let for A to complete the task, it took 5 days. Okay, I think there is some missing information and I am putting it here. Okay, so 1 by X is equal to nothing but 1 by 5. Okay, is equal to 1 by X, as X is equal to 5. Okay, so in 10 days what they will do is they'll do this much amount of work. Okay, so basically if they, so 10 into y plus 5 by 5y is equal to what? This much of amount of work they do. Okay, so they combinedly do 4 days. Okay, so A and B do combinedly for 4 days. Okay, then after that what they do is A leaves. Okay, so find the work done by A in 4 days. So A's work rate into time, right? So A's work rate is what? 1 by 10. Okay, into 4, that is 4. So actually here A can, not B, A can complete a project in 10 days. Okay, so work remaining for B to complete is B's work is equal to total work minus A's work, that is equal to 1 minus 4 by 10, that is actually equal to 6 by 10. Okay. So step 3 is use B's work rate to find the time takes to complete the project. So B's work by whole time is equal to 6 by 10 whole by time is equal to what? 6 by 10 by 10 is equal to 6 by 100. So time taken by B will be 100 by 6. So it will take approximately 16.66 days to complete the project for B. Okay. So let's see problem number 6. So if A, B and C can complete a construction project in 10 days working together. If A leaves after 3 days and B leaves after 2 days, before 2 days, okay, the project ends. How long will it take C to complete the remaining work? Okay. So the algebraic equation that will be involved here is what? ABC can complete a construction project in 10 days working together. So if A leaves after 3 days, so let's see. So find the work completed by ABC together in 3 days. So ABC together can complete the project in 10 days. This is given data. So their combined work rate is 1 by 10, right? This much of the project per day. So if A works at A's work rate is what? 1 by X, and for B it is 1 by Y, and for C if it is 1 by Z, this is actually equal to 1 by 10, right? So in 3 days they complete what? 3 by 10 of the project, right? So in 3 days they complete 3 by 10 of the project. So determine the remaining work after A leaves. So after 3 days the work remaining is 1 minus 3 by 10. Okay, that is equal to actually 7 by 10. So work completed after A leaves, but before B leaves. So B worked for 8 days because he leaves 2 days before the project. Okay, so this means that after A leaves, B worked for another 5 days together with C. In those 5 days, with only B and C working, 5 days into 1 by 10 is equal to 1 by 2 or 0.5. So determining the remaining work after 5 more days. Okay, so if A is 3 days and subsequent 5 days of B and C working together, a total of 8 days, the work remaining is 7 by 10 minus 1 by 2. So this is nothing but 2 by 10, or we can write it as 0.2. Okay, so C completes the work. So given B left 2 days before the project ends and the project duration is 10 days, C will work alone for the remaining 2 days. Therefore, C will complete the 1 by 5 of the task in 2 days. Okay. So problem number 7. So what it asks us is A and B can actually build a wall together in 12 days. Okay. If A and B are combined together, then they can build the wall in 12 days. If A alone can build the wall in 18 days, how long would it take B to build the wall alone? Okay. So find the combined work rate of A and B working together. So combined work rate is equal to what? 1 by 12. So use A's work rate to find the time A takes to complete the work. So A's work rate is equal to what? 1 by 18. So time taken by A is actually 18 days. So now let's find B's work rate by subtracting A's work rate from combined work rate. So B's work rate is equal to what? Combined work rate minus A's work rate. So using B's work rate to find B takes time to complete the work. So time taken by B is equal to 1 by B's work rate. Okay. So it would take, since this is equal to 1 by 36. So time taken by B will be what? 36. Okay. B would take 36 days to build the wall alone. Let's see problem number 8. So Tom can actually complete a project in 5 days working alone. If his work rate is 1 by 15 of the project per day, how long will it take him to complete the project working together with Lisa, who has also work rate of 1 by 20 of the project per day? Okay. So let's go forward. So calculating the combined work rate. Okay. Combined work rate will be what? 1 by 5. Okay. And Lisa's work rate is 1 by 20, right? So 1 by 15 plus 1 by 20 is equal to what? 7 by 60, right? Okay. For the project, his work rate is this much. Okay. So for this project, it will be this. What? 1 by 15. Okay. So 1 by 15 plus 1 by 20 is equal to 7 by 60. Set up the equation based on the combined work rate. So combined work rate is equal to 1 by 7 by 60. That is 60 by 7 is equal to 8.57 days. So it will take actually approximately for them to complete the task 8.57 days. So let's see problem number 9. So A can actually complete a task in 9 days and B can complete the same task in 15 days. So how long will it take them to complete the task if they work together? Okay, with A, working twice as fast as B. Okay, so work rate of A will be doubled. Okay, and the work rate of B remains as it is. So calculating the individual work rate. So A's work rate is what? 1 by 9, but it will get doubled, right? So it will become 2 by 9 for the project. Okay, or for the task, and B's will be same, that is 1 by 15. So this and calculating this becomes this. So 1 by 9 becomes this much. Okay, so the combined will be what? So if they work together, their combined work is what? 2 by 9 plus 1 by 15, right? So this is equal to nothing but 15, so 45. So this becomes what? 10 plus 3. Okay, so 13 by 45. Okay, so the amount of work is what? So the time taken is equal to number of tasks by rate, that is equal to 1 by 13 by 45. So this becomes 45 by 13. So this will take approximately 3.3 or 3.5 days. Okay, this much amount of time it will take, as you can see here. Okay, so let's see problem number 10. So A can actually complete a task in 6 days. Okay, the time A takes to complete a task is 6 days, but B can actually complete the same task in 8 days. Okay, and C can complete it in 12 days. And if they start working together and C leaves after 2 days, how long will it take A and B to complete the task? Okay, A can complete the task in 6 days. So A's work rate is equal to 1 by 6. B can complete the same task in 8 days. So B's work rate is equal to 1 by 8. So C can complete it in 12 days. So his work rate is 1 by 12. So if they start working together and C leaves after 2 days, okay, let's say they start working together. So 1 by 6 plus 1 by 8 plus 1 by 12, right? So this is equal to 6, 8, 12. So 48, yes. So 48 becomes the LCM. So this will be what? 8 plus 6 plus 4 is equal to 14 plus 4 is equal to 18. 18 by 48, that is equal to 9 by 24 is equal to 3 by 8. So 3 by 8 is their work rate. Okay, combined work rate. So if they work at this rate for 2 days, so 2 into 3 by 8. So 2 into 3 by 8 becomes what? 6 by 8. Okay, so the remaining work is 2 by 8. Okay, since 1 minus 6 by 8 is equal to 2 by 8. Okay, so 2 by 8, okay, is the amount of work remaining, and the new combined work of A and B will be what? 1 by 6 plus 1 by 8, that is equal to 24. So here 4 plus 3, so 7 by 24. So this will be 7 by 24. So this will be actually equal to 48 by 7 into 8. That is actually equal to 48 by 56. So 48 by 56 number of days it will take for A and B to complete the task. Okay, so we have arrived at the solution, that is 48 by 56. This much for A, B and C. So as you can see, work rate when all three work together is this much, and so the work done in 2 days is this much. So calculate the remaining work and set up it. So 7 by 24. So remaining work by combined rate of A and B. Okay, so what we are arriving at is 6 by 7. Okay, because 48 by 56 is equal to nothing but if we divide by 8 on both numerator and denominator, what we are left with is 6 and 7. So 6 by 7. This is the correct answer. Okay, so the task will take 2 days plus 6 by 7 days, that is 2.8 days, with all three working with just A and B. Okay, it will take A and B approximately 3 days to complete the remaining work. So let's see problem number 11. So if A and B can complete a task in 15 days working together, if A's work rate is twice that of B, how should the work be allocated? Okay, let's see. So let's say B's work rate is X unit per day. Okay, and A's work is 2X units per day. So set up a equation based on their combined work rate, that is x plus 2x is equal to 3x units per day. So calculate the time needed for them to complete the task together. That will be 3x plus 15 is equal to 1. So x is equal to 1 by 45. Okay, so this is the work rate for B. So let's calculate the A's work rate. So 2x is equal to 2 into 1 by 45 is equal to 2 by 45. Okay, so if the tasks need to be equally divided based on their capacity, B should be allocated 1/3 of the task, because B's work rate is 1/3 of the combined work, and A should be allotted 2/3 of the task, as A's work rate is 2/3 of their combined work rate. So let's see problem number 12. A can complete the task in 12 days and B can complete the same task in 18 days. They start working together, but after 3 days, what they do is C joins them. If all three working together complete the task in 6 days, how should the work be allocated? Okay, so let's go forward. So work rate of A is equal to 1/12, work rate of B is equal to 1/18. So for the first 3 days, only A and B are working. So in one day, together they complete work rate of A plus work rate of B is equal to 1/12 plus 1/18 is equal to nothing but 5/36 of the task. Okay, so in 3 days, 3 multiplied with 5/36, that is, okay, 5/12. Okay, which reduces to 5/12 of the task. So after 3 days, C joins, right? So now in the workforce, the work rate of C will also contribute. So together the three complete the task in 6 days. So in the remaining 3 days, A and B and C together complete 1 minus 5/12, the remaining, that is 7/12 of that task. So this means that the three of them together completed 7/12/3, that is 7/36 of the task per day. Okay, this is their combined workforce for the remaining 3 days of A, B, C. Okay, all. So A and B together complete 5/36 of the task in one day. So thus, if all the three complete 7/36 per day, then C's contribution is 7/36 minus 5/36 is equal to 2/36 or 1/80. This much is the C's contribution in the whole task. So the work allocation is A is equal to 1/12 of the task, B is equal to 1/18 of the task, and C is equal to 1/18 of the same task. So that's enough for today. Thank you.